Observability and SRE Part 11. This episode has 14 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Champion Challenger. How would you implement a champion challenger model deployment pattern in production? Here's a strong way to approach it. Deploy the challenger model alongside the champion, routing a small, controlled percentage of live traffic to the challenger while the champion continues serving the majority, and log both models' predictions on the same requests where possible for direct comparison. Evaluate the challenger against the champion on the same business metrics over a defined period before promoting it to champion status, and keep the previous champion available to revert to instantly if the challenger underperforms once fully promoted. Nice. Let's continue. Question 2. Kubernetes control plane. Explain what happens from kubectl apply to a running pod, including API server, scheduler, kubelet, CNI, and controllers. Here's a strong way to approach it. Kubectl sends the manifest to the API server, which validates and persists it to a controller, e.g. deployment controller, notices the new desired state and creates a pod object. The scheduler watches for unscheduled pods and assigns one to a suitable node based on resource requests and constraints. The kubelet on that node sees the assignment, pulls the container image, and instructs the container runtime to start the containers, while the CNI plugin assigns the pod an IP and wires up networking so it can communicate within the cluster. Great. Moving on. Question 3. Stateful set versus deployment. When would you use stateful set, deployment, job, cron job, or daemon set in real Kubernetes platforms? Here's a strong way to approach it. Use deployment for stateless, interchangeable replicas, most web services. Stateful set when pods need stable network identity and persistent storage tied to a specific pod ordinal, databases, message queues. Job for a run-to-completion task, cron job for scheduled recurring tasks, and daemon set when exactly one pod must run per node. Log collectors, node-level monitoring agents. Choosing the wrong primitive, like using a deployment for a database, typically causes data consistency or identity problems under scaling or rescheduling. Alright, next question. Question 4. CNI troubleshooting. Pods on different nodes cannot communicate. How would you debug CNI, routes, firewall rules, network policies, and node health? Here's a strong way to approach it. Start by checking whether the CNI plugins pods, e.g. Calico, Cilium Demonsat, are healthy on both nodes. Since a CNI agent crash on one node breaks all pod networking there, check node routing tables to confirm pod CIDR routes exist between nodes. Verify no firewall rule is blocking the pod network CIDR range at the VPC level. Check for a network policy inadvertently blocking the traffic, and confirm the nodes themselves are ready and not under network affecting resource pressure. Let's keep going. Question 5. Pod affinity. When would you use node selectors, affinity, anti-affinity, topology spread constraints, taints, and tolerations? Here's a strong way to approach it. Use node selectors or affinity to require or prefer scheduling on nodes with specific characteristics, GPU nodes, a specific zone. Anti-affinity to spread replicas apart so a single node or zone failure doesn't take down all instances of a service. Topology spread constraints for more precise, weighted distribution across zones or nodes than affinity alone provides. And taints or tolerations to reserve nodes for specific workloads. GPU nodes tainted so only GPU pods schedule there, while keeping general workloads off them. On to the next one. Question 6. Resource quotas. How would you design resource quotas and limit ranges for a shared cluster without blocking legitimate scaling? Here's a strong way to approach it. Set resource quotas per namespace based on each team's actual expected usage plus reasonable headroom, reviewed periodically rather than set once and forgotten, and use limit ranges to enforce sane default requests or limits so a pod deployed without explicit resource specs doesn't either starve or monopolize the node. Provide a clear, fast process for teams to request a quota increase when they have a legitimate scaling need, so the quota protects the cluster without becoming a bottleneck that teams root around. Good. Here's another one. Question 7. Helm rollback. A Helm upgrade failed and left resources in a partial state. How would you recover and prevent it next time? Here's a strong way to approach it. Use Helm rollback.